now access to the Hanyangin by this point. So I wanted to show you something, one thing about your assignment 0, because I keep getting questions about assignment 0, and I also had another question just before the last class about reading your textbook. I think that was a question. 맞나? Who was it? Who asked me the questions? Anyway, one of them was asking me a question about textbook. How do you start reading the textbook, right? It's all written in English, so it's a bit difficult. It needs some time to get adjust from Korean reading to English. But like chapter 1 and 2, this is what I usually do. I just flip around the pages. I look at it like a newspapers for the first time. I don't read sentence by sentence. I don't do that usually. I just flip around and see what kind of diagrams are there, pictures, and then I do it a couple of times. I don't read word by word yet. And then from chapter 2, 3, you will see a bold image, bold text, little black text. Every vocabulary they think it's important. They actually mark it as a black bold text. I would usually read that first, read the sentences, and then maybe I'll go back from the beginning and start reading like newspapers again. Okay, so do not read like you're solving a English essay questions in your 수능. Okay, 막 이렇게 외우고 쓰고 이렇게 읽지 말고 reading it like a newspaper first. Later, you will need to read it anyways because I'm going to ask questions from the textbook that requires to read certain sections in chapters for more details. So don't worry about too much. Just start flipping the page. That's important. Hopefully, I make myself clear about reading your textbook. I wanted to see you I wanted to show something in the iPad about assignment 0. Still, I explained it briefly last class. Maybe I can show you something here. It's a small company called Dalmic Labs, I think. It's a very small venture company. It's been around 1 year or 2. They just start selling this band, not yet, but it's $149. I think 얼마야? 15만 원? They start selling it starting sometime this year, mid of 2014. So things like this small companies, if you can find it, but it's interesting technology, right? It's very popular too. They also raise a lot of money. In fact, actually one of the Korean companies invests money in this venture company too. Not Korean. The company is owned by Korean. So things like this I'm looking for. Maybe you can report one paragraph on what this company is doing and what are their specialties of building such system, what kind of softwares they might be using it, and stuff like that. Their possibilities for future. Not so sure they will be successful in next years, but still it looks quite interesting too, right? 재밌어 보이죠? Yeah? It's not a big company. So I'm looking for companies like this. If you can find it, do a report, just write down the company name, their website, and then one paragraph of describing what they're doing. Next company name, maybe website, and then another paragraph explaining what they're doing. Interesting. Why do you think it's interesting? So something like this will be great. Actually, these people came to Korea a couple months ago. The guy who found this lab. Do you know how old he is? 몇 살일 것 같아? He found this company right after graduation of, no, he was doing his 3rd year of a university. 3학년 때인가 4학년 때 만들어서 I think he's now graduated and he's doing it at this moment. I hope you guys get the idea of what I'm asking for the assignment 0. Okay? 됐죠? 얼핏? Okay. So we were still in the discussing in pseudocode and different type of stuff, different type of structures, operations that you could use. Mostly we're given a problems and try to figure out the way of writing its solution down in clear ways, pseudocode ways. Of course, in your textbook, they actually suggest certain formats to write down pseudocode, get, set, while, what else were there? What's it? Well, we know what it is, yeah. Primitive instructions and stuff like that. And then we start discussing this loop, pre-test, post-test, and if you check your conditions at the beginning of the loop, that's pre-test. If you check the conditions at the bottom, then it's a post-test. Things that we know already. What's wrong with my iPad? 오늘 일진이 안 좋은데? Something is not right today. Okay. Okay, and then we did take a look at this gas mileage, calculating gas mileage, average gases, well, average miles per gallon examples. And then starting from one simple example, they start adding a conditional statement to make a judgment whether you are getting a good gas mileage. And then final one was adding a big loop on the outside, so it keep asking you the same question over and over again, right? It's not. Am I in the different class? We discussed this, right? 그지? 맞지? If I'm in the different page, please let me know. 아니야? 내가 이거 안 했나? 했지? Okay. And then there was some suggestions for the pseudocode writings, but I also mentioned that it's something that you can ignore too. As long as you can write your own pseudocode in your own precise, clear ways, I would accept it. So don't worry about it too much. But it's a suggestion that you could follow. And then we start discussing this first example, algorithms. Not algorithm, yeah, algorithms. It's more of a natural language given to non-negative integers. A, b greater than 0. If you wanted to build a program that a, using a, if for b addition, b number of times additions for a. Right? And then I was drawing very simple algorithm like using loops to explaining what to do, right? The conditions. If certain integer I is less than b, while I is less than b, then you're doing a plus a, right? Until you reach b, and then you exit the loop. That is a very brief algorithm on this particular solution, right? 왜 그래? What's wrong with you today? What class did you guys have in the morning? 뭐 했어? 경영학개론? Who's 안종찬 교수님인가? Okay. 왜 난 아무 소리 안 했다? I didn't say anything. 경영학개론. I know. But even though I never took any business courses, it could be a bit. I didn't say it. You say it. It will be interesting soon. Business courses usually more interesting. At the end, they probably give you a lot of different assignments at the end. So don't worry too much about it. That's why you guys are a bit exhausted. All right. So this is also pseudocode representation that I also drew on the board last class. Get value for A and B. This was the point that I didn't explain my own algorithm, right? If it's 0, you don't do any. You don't need to do any of the loopings, right? Because either one, if A0, B0, then it's always going to be a 0. why are you going into a loop? Let's save some time. Don't do it. That's why they put an extra checking condition in the top. Well, it's okay. Even if you don't have a checking conditions, still okay. The single loop pseudocode will work. You know? It doesn't mean it doesn't work. It will work. This one is okay, but slightly better, I guess. Slightly better. Later chapter, the next chapter, we're discussing on there could be many different pseudocode or many different algorithms for same problems, right? Everyone, if I ask you, even for this simple problem, if I ask you to write it, how many of you here? Around 50? I will probably have 50 different looking algorithms. They would do the same thing, but they all look different. So how do you determine which one is better than the other? How do you determine your algorithm is better than your friends? How do you determine simpleness? Short is also one thing, right? Short is also one thing. Maybe there is slightly more than being short. Maybe, let me rephrase that question. Maybe. Whose algorithm is faster than the other? Maybe that's also one thing too, right? It doesn't mean always faster is good, but it's faster means they're doing something slightly better than the other algorithms, right? We're gonna discuss on that part, how do you compare, how do you make a distinction between different algorithms doing same stuff. That was coming up next chapter. Hopefully we can cover some today. I'm not so sure. So just have that in your mind. We're going into that place soon. Until then, we're going to look at another algorithm. Hopefully it's going to be a bit more difficult. Like I also told you, because I give you the pseudocode right away after I explain the problem, it problem looks a bit easier. But it's not actually. If I just giving you the problem without any pseudocode, you have to think at least maybe an hour to come up, not even an hour, maybe half an hour to think of the algorithms. Okay, looking. What is the function? What do you do when you open up a website? Let's see, if you go to naver.com, I like to find out something. What do you do? Search. I do a search. I type a keyword that I wanted to look. What is searching? Yeah. Maybe I give a keyword like coffee. Type coffee in my Naver screen, then it will probably give me any blog messages, news articles that matching coffee. If I ask you to write an algorithm to find a coffee given text, can you do it? So there are many different searching algorithms. You don't have to do it. Later, you just use someone else's algorithm to do it. This is another thing. Sometimes algorithms, pretty much every single algorithm that you can think of is already existing. Lots of people working for a long time. It's already there. So in practice, it's more important to know how to find those algorithms in your problems, to match your problems. You don't have to write it all the time from nothing. Okay? That's another thing we will see. So algorithm discovering, finding a solution to a given problem, sequential search, standard algorithm for searching a unordered list of values. 오늘 내가 이상하구나. 혀가 꼬이고 말이 꼬이고. 내가 아침에 수업을 듣고 왔나 보다. Unordered list of values. What does it mean to have an unordered list of values, assuming that we're just dealing with the numbers, integers? Unordered. 1, 2, 3, 4, 5, 6, 7. That's ordered, maybe. Whether that's ascending or descending order, it's sorted. Unordered, just random. Maybe I have a list. How do I write a list? Maybe 2, 4, 6, 1, 6, 11, 10, unordered list of numbers. 이상하네 오늘. 미안해요. 이런 적이 없는데. What do you do if your computer keep bugging you? What's your next solution? Huh? Restart. I know why. I just did the iPad upgrade to iOS 7.1. 이런 나중에 할 걸. I'm gonna have to look it up. Anyways. So 2, 4, 6, 11, 10. Okay. What if I'm asking you to write an algorithm? I'm looking for 10. Can you write an algorithm to find that whether I have a 10 in this list or not? Without even looking at the pseudocode, what would you do? What would you do? First stuff. What would you do yourself? No programming. 어떻게 봐? We already know because you already scanned through the numbers with your eyes. But when you actually scan it through, you're probably doing this. You know it's 10. 10, no. 10, no. 10, no. 10, no. Oh, 10 here. Or some people probably look it from here to here. It doesn't really matter. But anyway, we're doing it either ways, right? Okay, let's try to write that into an algorithm, but it has to be a sequential search. As an example, sequential search means, again, what was a sequential? From 순서대로, right? If I choose to do it from this way, 1, 2, 3, 4, 5, 6, 7, doesn't really matter. If you're lefty, you can go 1, 2, 3, 4, 5, 6, 7. So in terms of pseudocode, cool. Okay. Let's take a look at this sequential search algorithm. Get a value for name N1 and N1 10,000. Okay. And T1 to T10,000. So have that is very simple sequential search. This is another type of sequential search. For example, N representing a name. Representing a name. And T means telephone number. Your cell phone number, for example. So I have 10,000 numbers, 10,000 names and 10,000 telephone numbers. And N1, my name's Young, okay. Young's telephone number is stored in T1, okay. So in order to find my name and my telephone number, they probably have to do this. If name is equal to N-1, N1, Young, then print the value T1 sequentially. Then I might have to have 10,000 if statement. What if my name is at the very back? My name's in T10,000. Then I have to go through them all until I match one. Is it a good algorithm to do it? Probably not. But it doesn't matter. It doesn't matter. It still works. It's going to take a bit longer than the others, but it still works. Maybe we can start practicing to write the simple sequential searches first. So it's not so much different from this to that, right? That's search. That is search. Second attempt. So hopefully it will be a bit better. Instead of having a 10,000 if statement, perhaps we could just simply use a loop, right? Loop. What would you do? Given values of 10,000 names from N1 to N10,000, according to each n, I have telephone numbers T1 to T10,000. Okay. Set the value of I to 1. I to 1. I'm just going to follow. Set certain valuable name found to no. We briefly discussed this. Okay, I have some valuable name found, but I'm going to set it to no. What was yes and no? We briefly discussed last class. It was something called Boolean, right? Yes and no. So this one will store not an integer, it will store only yes and no. So I'm going to set it as a no, while found is no. So at the beginning, my found always will be no. So I can go into the loop. While found is no, let's do step 4 to 7. 4 to 7. If name, the given name, let's say Young. If Young is equal to ith name on the list of ni, so I'm going to probably do this. If Young is equal to n1, because ni, but I is starting from 1. If it is, print n1, right? So after this point, I'm going to simply replace 1 to I. I1, I2, I3, I4. If the name is found in the list, okay, I have to indicate that name is there. So I'm going to set this found to yes. If it's found, yes. Otherwise, you keep adding I. Do you know why they call it as a C++? Because you can do this. I++ means I 1 plus 1. Well, I'm not so sure it's true, but they actually to make a joke, I++. So I could write it like that. So if it's there, I found it, and because I changed my found to yes, if I go back up, is this condition still okay? No, right? Still, so exit the loop. I just found my number according to the name of Young. Sequential search, okay. 10,000 if 2, simple looping examples. This is also similar, but they have extra conditions to checking I. And if previous algorithm, probably, if they found it, they're going to print out the name and probably don't say anything else. In this previous example, what happens if I don't find the name that I was looking for? What would be the message? Well, there would be no message, right? If I found it, only they're going to print out the telephone number. Otherwise, they don't express anything else. This, the third one, they will print out the message that if found is no, then there is no name that you're looking for in my list. So, in order to do that, I have to count the the number of eyes. Number of eyes? No, the value of eyes. If I hits 10,000, means I don't have anything else in my list. I should quit. When I'm quitting, I also print out the message. My found is still no, even after I went through all the things in my list. So print out the message. Sorry, your name is not in the list that I have. Okay. tiny things can be added. Tiny things can be added in this way. So another example of fixing your pseudocode, adding a slight bit more functionalities like this. What would you do if you want to improve this algorithm, finding sequential search? What would you do? Let's say you have a long list like that. It's a wild guess. 그냥 찍어봐. I like to improve these algorithms. What would you do it? But you still have to do in sequential search ways. 몰라? 머리 좋잖아. Your IQ is higher than mine. Huh? What if I divide up this list into half? And running the same program separately. Then in theory, it's going to be, if you're lucky, then you will find the name that you're looking for a bit faster than single search, right? What if you still want to improve more? Maybe divide it more. I don't know. There must be some kind of boundary. Or what if your list is sorted? Means I have 2, 4, 6, 11, 10. Okay, before I do a search, I probably do a sorting first. So I create a new list, 1, 2, 4, 6, 10, 11. And then I'm gonna do looking for 10. Will it be faster? Will it be faster? 빠를까? 똑같아. Maybe in sequential search, yes, it will be probably the same. But in different type of searching algorithm, there is a chance that we can do this much faster ways. Maybe if it's a sorted, maybe I pick in half. Okay, this is not a good example to pick in half. Let me add 5 just in case. Okay, pick in half. Okay, what would you do? Instead of starting from here or here, I start from here. So the value I'm looking for is 10. What would you do? 그냥 아무게 얘기해. I'm not looking. 내가 틀린다고 때리게 하겠어요. There is no right or wrong. Okay. 10, 5, compare. Okay, I'm looking for 10, but 5 is. 야, 진짜 큰일 났다. 5 is smaller than 10. So because it's sorted, I only need to look at the list from this side from now. I just remove my data space into half. Do the same again. What's middle value in here? Maybe I just pick a 10 here. In this case, lucky. 10 is in the middle, so I'm done. So instead of doing a maybe 10,000 comparison, I just did a maybe twice. Got my value, right? So there are different way of doing this later algorithms. Let me quickly do something about this. So in the second chapter, they only discuss in the sequential search and just give you idea on how to write pseudocode. But later chapters, we will be discussing this type of sorting algorithm, better sorting algorithm. In this case, faster algorithms out there too. 뭐 질문할 게 없죠? But apparently, you're doing this anyways in your brain. You've been doing this all the time for your life. But you just simply didn't care before to write it down in your own ways. Can I give you the assignment, programming assignment to do this? Can you do this? There you go. If I ask you. 아마 you would do this later. 아마 어차피 C 코스에서 할 거예요. You probably do this type of coding in next class. So I'm probably not going to give you, but I probably give you how to analyze this type of algorithms. Is it faster, slower? Can you make it better? Okay. Next example. It's going to be boring. Another example after another example. Bigger, biggest. Library. Like I say, later if you're actually doing a development, most of times you don't need to implement your own algorithms. There is already good algorithms that is implemented. Simply you can download it and use it. So that is something called library. It's a book library, so it's like a library of algorithms. So in your C courses, they probably start teaching you like include something. Those are the libraries that you can use. So what's a good programmer? I don't know. I know that you guys not starting yet. Who's a good programmer? Good programmers. Okay, they write good programs, but sometimes good programmers do this. They know where things are. They know which library to use and simply use it instead of writing their own. Dumb programmers writing their own. Dumb programmers writing their own, also very good programmer writing their own too. So somewhere in the between, like us, we should use someone else's libraries. Okay? So don't try to do it on yourself yet. So problems, given a value of n greater than equal to 1, a list containing exactly n unique numbers. Unique? Unique? How do you define a unique here? Is this the list are they talking about? They say we must have a unique elements in the list. It's not unique, right? To appear twice. So list like this, probably unique. Okay. So unique numbers called A1, A2, AN. Find and print out both largest value in the list and the position in the list where the target value is occurred. What does that mean? 대답 안 하면 안 할 거야. 대답 안 하면 나갈 거야. 너무 쉬운 걸 물어보는데 대답을 안 하면 나중에는 뭘 물어봐도 대답을 안 할 겁니다. 뭐야? 영어 수능으로 영어를 보고 오시는 분들이 무슨? I know you guys are translating. So they want you to find the biggest number in the list where they are located in the list. Okay? That's the problem they wanted to solve. So A1, A2, A3, A4, A5. Okay. How do you determine the location of the list? Maybe first location, second location, third location, fourth location, fifth. Okay. What's the biggest number in this list? Oh, someone says 4. Sorry. 됐지? 14. 별별 걸 다 해야 된다. I feel like I'm talking to elementary kids. 14. How do you know 14 is the largest if you're starting from here? We all know because you know all the numbers, what's happening next. Right? So in theory, you have to go through the entire list in order to find out the largest in the list. You cannot stop when you hit 14. You don't know what's going to be the next after 14, right? So you need to go through the entire list. That's probably the first condition in order to find it. What would you do? How would you start with this pseudocode?
Starting from A1, you can compare number, so you can switch the value, and you can keep doing this until the end, so you can find 14 is the biggest number.
I don't need to explain. He just explained this. But it's a bit complicated when he speaks, right? That's why natural language pseudocode, right? Pseudocode. So yeah, you guys doing this in your brain anyways. He just explained it. You guys decide to not to speak. That's the only difference. Start from first position. Okay, my initial value is 1 because I didn't see any other values in the list. 1 will be the biggest one so far, right? Okay. I start from here. Okay, this is my current value, current. Because I don't know any other values, 1 is the biggest. Okay, I'm going to put this as a current. Let's move to the second one. My current value is 1. My next value is 2. Which one is bigger? 2. I'm sorry, I'm not going to ask you these questions anymore. 카메라인데 약간 쪽팔리기 시작합니다. 2. 다른 거 할게 다음부터는. 미안해요. 2. Okay, but the algorithm is looking for the biggest. So far, 2 is the biggest. So I'm going to change my current biggest value to 2. Now is my 2. Ignore 1 anymore because 1 is smaller than 2. Okay, 2. My current is 2. Next one, 4. This is a very stupid example, but 4. 2. So I'm going to tell my current to 4. 14. 아이고. Right? 14. 3. Next one. Obviously. So I'm not going to change my current to 3. I'm going to stay with the 14. But while I'm doing this, I also need to do what? Position of the biggest one. 4. Print 4. What happens at 3? Still my current is 14. I also try to look at next one. There's nothing else. So I stop the algorithm. Stop the loop actually. So what I have in my current is 14. Location is 4. Done. Done. Just did a finding largest elements in the list. Very simple steps to think of. 이거 뭐 if I ask you to write in pseudocode, anybody can do this, 그지? 아니야? 할 수 있어요. 안 해봐서 그렇지. 너무 쉽게 할 수 있어요. So let me just look at it. This nicer way of representing. Get a value of n, the size of the list. N in this case is what? N is 5, 그지? 1, 2, 3, 4, 5 elements in the list. Get value of an to an, I have that. Set the value of largest. I use the term current. I will use it largest. Okay. Set the value of location is 1 because I'm starting from 1. So location 1. 그리고 뭐 똑같이 set the value of I 2. Why do they set the value of I equal 2? Because I know where this is, I need to start comparing to this. So second position, I2. There could be any other ways to do this, but while I is less than 0, and then if AI is greater than largest so far, then set the largest so far to AI, the new value. If this is bigger, then set this largest to 2. Exactly same. Set the location of I. At this point, the largest is 2. Largest location is 2. So location will be 2. They will keep changing it until they hit 14. Blah, blah, blah. At the end of the loop, you exit the loop, you just print out the values of largest and location, which is 14 and 4. What I explained exactly written down there. 쉽지? 미안해. 초반 매트 클래스는 너무 쉬워요. 미안해. 죄송합니다. 진심으로 사과를 하면서. Can it be a difficult algorithm? Yes. Like I mentioned last time, there could be problems that difficult to write an algorithm for, like scheduling algorithm for 택배 아저씨s, right? You're lucky that we're not discussing that algorithm in this class. I don't even know how to do it. So just take a look at it as an exercise. Next, meet your match. Pattern matching algorithms. What's a DNA? What's a DNA? Have you ever taken a look at how DNA look like? I don't know either. I only seen it from a newspaper. They seems to have like this. It consists of 4 letters like G, T, 뭐냐? Anybody take biology in your high school? No? 나도 몰라. G, T, D, N, I don't know. They only consist of 4 letters. But if you take a look at it, these 4 letters, G, 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 T, G, 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 G. Millions of sequence of characters out there. G가 맞니? This may be wrong. It's 4 letters. 뭐 단백질 그 4개 가지고 하죠. 아는 사람? Doesn't matter. Let's come up with our own DNA then. No one seems to know biology. Our DNA is A, B, C, D. A, B, C, D. Okay. And the sequence of DNAs we wanted to see is A, B, B, A, C. Continuation. So this is a pattern. The pattern that I'm looking for example, is A, B, B, A, A. This is the pattern that I'm looking for in long list of characters that I have. So this is a data set. This is my input. It says pattern matching. Pattern matching. So if this is a sequence of DNA, A, B, B, A. It has a pattern, right? Okay. There is one pattern. Maybe there is more out there. This is a problem set they wanted to explain. Can you build an algorithm to find that pattern? It's a bit worse than this. You're going simpler. This one make you thinking. Is it? So have that in your mind. Let me read it first. Process of searching for special patterns of symbols. In this case, our symbols is A, B, C, D. Just because we don't remember, none of you remember the basic component of those four letters of the protein. 맞나? 단백질? Large collection of information is assisting microbiologists, genetic people studying and map the human. How do you read that? Genome or genome? In German, genome, 맞나? I don't know which one is correct. Map. This is my match. So assuming if this sequence have this pattern, it's a human being. Something like that. So, of course, to be a human being, it has to be really, really long line of sequence. Or if you apply this type of algorithms, then you are given 2 different subsequence of symbols, then how similar they are between 2 line of a symbols. We often hear that, right? 뭐 그러잖아. Monkeys and human beings, the only difference between the DNA sequence is what? Less than 1%? So it's the same idea. They use such algorithm to determine that. Okay, what would you do? 길다. What would you do? How would you start? Remember, you can also speak in Korean. You can ask me in Korean too. Okay? Don't be afraid if you 하게 뭐 영어냐 한국말의 문제가 아니겠죠. 그냥 하기 싫은 게 문제겠지. 그죠? So, 어떡하니? Pattern matching problem. So you're given some text composed of n characters. That will be referred to as T1 to Tn. You're also giving a pattern of m characters. M will be less than n because it's a pattern. Pattern cannot be longer than the data itself. So it will be represented as pattern 1, P2, P1, P2, Pm. The algorithm must locate every occurrence of the pattern within the text. So maybe I need to report how many times does the pattern occur in the long list of symbols. Okay. The output of the algorithm is location of a text where each match occurred. In this case, 1, 2, 3. At position 4, first pattern occurs. Between 4 to 5, 6, 7, 8. Between 4 to 8, first pattern occurred. I need to also report that, not just how many times it did occur. So for this problem, location of a match is defined to be index position in the text where the match begins. Well, so what should I print out in this case? 영어로 수업하면 다 알아듣지? 그지? 그지? 갑자기 의심이 확 들어옵니다. 그지? It says index position of the where match start. So in this case, match start at position 4. So it means they want me to print out 4. 4. Okay. 내가 여러분들 선배들한테 속은 게 하도 많아가지고 맨날 못 알아듣는 척하고 이러고 있어갖고 웬만한 거에 이제 속지 않습니다. 2년 동안 단련이 돼서 거짓말하지 마, 이 거짓말쟁이들아. 다 알아듣고 일부러 못 알아듣는 척하는 거 다 알고 있습니다. 1, 2학번들한테는 속지 않았는데 1, 2학번은 정말 모르는 것 같았는데 1, 3학번들을 날 철저하게 속여가지고 1, 4학번은 절대 속지 않습니다. 그러니까 모르는 표정 하지 마. So that's 또 선배들한테 가서 내가 그렇게 얘기했다고 얘기하지 마요. 또 삐질라. 그렇죠? So that's the algorithm. They discuss on the inputs. They also discuss what to produce as an output. Okay. Okay. Without even looking at this, what would you do? What's your idea for doing this? Because the algorithm they represent is also long. What might be a rough idea to start in this part? 고민을 시작한 거야. T1, T2, T3. P1, P2, PM, M is less than N. It makes sense. 그죠? Data, pattern. Okay, what would you do? 찍어봐. 어떻게 하겠어? 아까 sequential search 할 때 얘기 잘하던데. What would you do? Later they mentioning something called sliding window. What if I match one by one? Let me do a match. A, B, B. Okay. Within this 5 characters only, I do a testing. First position A is A, yes. First position of B is A, no, right? So I don't need to do rest of it. Okay. What should I do? Let's move. A, B, B, A, A. A, B, no. Let's move. A, B, B, A, A. A, B, no. Move. 죽겠지. Imagine you try to do this with your own hands. Let's say this sequence is about 10,000. A, B, B, A, A. A, B, B, A, A. Got it. Right. First match. Okay, report. My current position 4. My count, how many were there? Now it's 1. Okay, what would you do again? Next. I'm sliding my window. I'm going to call this as a window. Window size of 5. Sliding 1, sliding 2, slide 3. By one position. By one position, one at a time. It's going to be slow. It's going to be slow. Especially dealing with a large patterns and long sequence. That's why DNA sequence matching, genome testing takes supercomputers to do that. So I'm going to call this as sliding window algorithms. Sliding window algorithm. It's used everywhere. Other similar ideas as being used. So I give you the rough idea. What's your job next? Make a pseudocode for me. 이거 말고 다르게 할 수 있는 방법이 있을까? If you have a brilliant idea, let me know. 아마 있겠지. 있겠죠. If you're interested, try to type on Google and DNA sequence matching algorithms. DNA matching algorithms. It will probably give you very difficult looking algorithms, and some algorithms you can download their source code and you can actually try. But don't ask me a question. I don't know too much. I have no idea. I'm not a biologist. 내가 뭐 생물하는 사람이 아니라서 뭔지는 잘 몰라. 뜻은 몰라. I know how to write an algorithm, but I don't know what it means. Okay. That's that. Step 1, matching process begins. Step 2, slide forward. Slide forward. Slide that way. One by one. One character slide. Slide by one character. One at a time. It's a bit of a poor slide. Can you get this from these 2 lines? 좀 설명이 좀 부족한 슬라이드 같긴 같지? 그치? 솔직하게 얘기해. 난 딱 이거 설명하는 순간 뭐 저렇게 쉬운 알고리즘을 설명 하나 했다. 손 들어봐. 괜찮아요. 내가 공공의 적으로 만들어줄게요. 근데 누구나 생각하면 여러분들 머릿속으로 이미 다 하고 있던 거예요. 다 그렇게 보지 어떻게 보겠어? 그죠? 랜덤으로 막 잘라서 볼 거야? 여기도 맞춰보고 여기도 맞춰보고. 그렇게 하나, 이렇게 하나 어차피 다 해봐야 되는 건 마찬가지죠. 그죠? So what I just said simply describe. It's a bit wordy. It's a bit wordy. I would still call it as a pseudocode, but I'm sure you can make it a bit simpler like this. get the value of n and m, the size of text and patterns respectively, get the value of both text t1 and p1 till m and n. Set k, starting location of attempted match to 1. So I'm going to probably use some value called k1 because I'm starting with 1. Next time, k2, like this. Okay. Keep going until we have fallen off the end of the text. What does that mean? It simply means when this window hits the end, falling off the text. Attempt to match every single character in the pattern matching begins. A, B, B, A, A, B, B. So you need another small algorithm to matching 5 characters. Algorithm within the algorithm. So, need to match. At position for the K, and if there is a match, print the value of K where I begin to match. In this case 4. I do that until I hit the end of a sequence of symbols. Done. End of loop. Stop. So what he told us, no, that was pattern matching. What I told you, it's a bit simpler format. Hopefully pseudocode is much better, like this. It's exactly the same, but you have to play around with this J's and K's just to make sure that you're in the right location for these small values. Okay, so it's not much difference. Not much different. Let me go back to that anyways. So example of high-level constructions. Sliding window that I mentioned is high-level construction, high-level ideas of what I will do. Things like if it was a sequential match, sort the entire list ascending order, attempt to match entire pattern against the text, find the root of equation. It's okay, don't worry about it. Abstractions. This is also another keyword, abstractions. Use of high-level instructions during the design process. Abstraction I'm going to discuss more in the next few classes. Abstraction usually means you try to simplify the problem. So you can just focus on the overall ideas instead of worry about J's and K's. Before you actually worry about J's and K's, let's forget about those tiny details. Let's simplify the problem, get the main idea, like sliding window. Match 1 by 1 by sliding by 1 character. That's my abstracted solutions for these problems. Top-down design, viewing operation at the high level of abstraction. That's what I'm doing, right? High level. I don't jump into the code right away. I don't jump into the pseudocode right away because this requires a bit more thinking. So I do a rough level and then try to translate. Previous 2 examples, like sequential search. Well, what was it? The biggest and stuff. Those things are, you don't need any abstractions at the beginning. You can just directly start writing the code if you wish, because those are simple ideas. But things like this might be a good practice for your abstracting the view of the problems. First draft of a pattern matching algorithm. Well, first 3 lines same. While k is less than equal to n minus n plus 1. Maybe, and this, let me just look at the structure. There is a big while loop, and there is a one smaller while loop inside. See? Big one, and within the big one, there is a smaller one. What would that be? Big one, sliding this 1 by 1, small one matching each. Just look at the structure and just simply translate into that part. Okay? 크게 뭉태기를 움직이는 게 하나씩 움직이는 게 위에 있는 큰 룹. 그 안에서 하나하나 매칭해야 되는 게 또 있었죠? 조그만 룹. So even if you don't understand 100% in this procedure, you can just see the big picture from the pseudocode. Okay? It's not going to be so much different from what I explained in here. 안 할래. I'm not going to explain this again. I'm going to repeat myself anyways. So if you have this, what would you do? What did I show you last class? With a very simple example. I was actually plugging the numbers. N equal J1, K1. And each line, if this value change, J2, K2, simply plug these numbers in. You keep following where you are. So start with a very simple example. Maybe pattern of 2, AA. Your target string is maybe AB, AA. Try this and see whether J, K, and M values, how they change. Whether this algorithm actually works or not. Okay, that's a good practice to follow the algorithms. And it's a good debugging step later. Debugging means fixing your algorithms, fixing your programs. Does it make sense? 말 돼? 왜 그래? Do we have any other algorithms? Probably in your textbook they may have a bit more. But usually this pattern matching algorithm is one of the difficult ones for the beginners to start with. Yeah, 어쩌려고 그래? What if I start asking you, write a pattern matching algorithm for that 2 characters? Program in C. 죄송합니다. print, sorry. If match found, no, print sorry. Okay, that's a one practice. Anyway, again, like I told you last week many times, start thinking like this matters. It doesn't matter whether you program or not. Start thinking like this does matters later. So you can go into programming much easier ways. So what you're covering in the next class, C class, will probably teach you syntax and actual practice. Try to match between 2 courses, okay? He also give you very interesting things to do with your own C programming experience. Okay. Any questions so far? 질문? 벌써 가려고? 질문? Okay. So in summary, I think it's end of chapter 2. End of chapter 2. Algorithm design. First step in developing an algorithm or developing your own program. Algorithm design must ensure the algorithm is correct. One thing we didn't discuss too much is that pattern matching algorithm that we studied, is it going to apply to all sequence of symbols? Is it going to work all the time? I'm not so sure. There's no guarantee. If I change something in the data and the inputs, there's no guarantee this algorithm work all the time. So that's another problem that we need to discuss later. Ensure the algorithm is sufficiently efficient. Is it fastest pattern matching algorithm out there? Probably not. There must be better ones out there. And here, better means faster. Efficient also sometimes meaning for taking less memories and less CPU time, but let's just stick with the time. Maybe there's a faster algorithms out there to do this. Pseudocode used to design and representing algorithm in, it's not formal language, but between natural language and formal language. So just before step going for programming language. Okay. I'm gonna explain. We'll continue. I'm gonna finish discussing the slide next week. We're done here anyways. No questions. I'm gonna call out the attendance now. 질문 없으면 출석 부를게요. Okay?